Hey everybody, this is Mr. Piercy, and in this video what I'm going to be talking about is a type of reasoning that's used generally in mathematics, known as inductive reasoning, and specifically in the logic unit of geometry where we talk about the way that we identify true statements versus false statements, and there's two different types of reasoning, inductive reasoning and deductive reasoning. So today we're going to be looking specifically about what inductive reasoning is. Well, generally speaking, inductive reasoning is the process of looking at some kind of a pattern, and based on what we see in those patterns, we're trying to use that to make predictions about if it continues, how is it going to change in the future. Now, those statements that we make based off of what we see, those are known as conjectures. Now, a conjecture can be true, but it could also be false. If a conjecture is false, you can usually find a reason for why it could be false, and that reason would be called a counterexample. So let's take a look at the pattern that we see here and see if we can use some inductive reasoning to figure out what's the fourth figure going to look like. Well, it says to sketch the fourth figure, and so what are we doing here each time? Well, if we look here, what it's telling you is that each rectangle is divided into blank as many equal regions as the figure number. Well, what is the figure number? This is something that if we were in an algebra classroom, we might want to just take it and call, we have x numbers and we have y numbers, whereas the x numbers is the figure number and the y numbers would be the number of equal regions. So for instance, this is when x is equal to 1. So when x is 1, I have two equal regions. This second figure would be when x is equal to 2. So when x is 2, I have four equal regions. Here, the third figure would be when x is equal to 3, and you can see when x is 3, I have six equal regions. So it makes sense, according to what the pattern that we're seeing is that if I say x is equal to 4, I should have a figure that's divided into 8 equal regions, because what we're noticing is that whatever x is, we're doubling it to find out how many spaces or how many equal parts we're dividing it into. And in each one, we're noticing that the shaded area is either at the bottom or the bottom left. In figure 1, the shaded area is at the bottom. In figure 2 and 3, the shaded area is at the bottom left each time. So based on what we're seeing, I think we're going to divide this into eighths. So when x is 4, we're going to have 8 equal sections, and the shaded area is going to be in the bottom of the figure, in the bottom row, and towards the left. So based on what we were seeing in the pattern, as far as how many equal regions the figure was divided into, where the location of the shaded part of the figure was, that's allowing us to make a prediction about what the next figure in the pattern is going to generate. So go ahead and take a moment and show me what would the fifth figure be in the same pattern. So go ahead and pause the video and draw out your pattern, and when you're done, hit play and see if yours matches mine. All right, so hopefully we have our fifth figure drawn out, and we should see it drawn into, when x is 5 in this case, it should divide it into 10 equal regions, where the lower left-hand corner is still going to be the one that's shaded. Now here, describe what it's asking us to do is describe a number pattern. Okay, how is a number pattern changing each time? Again, back in Algebra 1, you would have looked at this, you would have looked at a table to see, does it have a constant rate of change, to tell if it's linear, and if it's not linear, how are the numbers increasing from one term to the next. So we want to know, how is this number pattern changing, to figure out what are the next three numbers in the sequence. Well, starting from -1 to a -4, well, the numbers are getting smaller. to go from a -1 to a -4, I could either subtract 3. So if I said here, what I'm looking at, if I look between those two numbers, I can say -1 minus 3, and that gives me my -4. Well, if I look at the next two numbers here, if I say -4 minus 6 or minus 3 again, that gives me a -7, not a -16. So subtracting 3 each time doesn't seem to work. So is there another method that we could try? Well, looking again at the numbers here, I'm going to go back to my red. Looking at the numbers here, I can take a -1 and multiply it by a 4 and get -4. I could also take -4, multiply it by 4, and I get -16. And if I try the last pair of numbers, -16 going to the -64, if I multiply -16 by 4, that's also going to give me a -64. So what we're seeing is we're taking the number and multiplying it by 4 to get whatever the next number in the sequence is going to be. So the next three numbers, I'm going to say -64 times 4, get -256, multiply that by 4, and so on. So the next three numbers are 256 negative, -1024, and -4096. Sometimes the patterns can be a little easier to discern than others. Sometimes it really helps to have a model, to draw a figure to make sure, see what is it going to look like. Now here the example that it's giving us is 5 non-collinear points, and we want to make a conjecture about, well, how many different ways can we connect them? This is also a very popular question dealing with handshakes, whereas the number of points would be like people, and if each person was going to shake hands with somebody else that was there, how many times would people shake hands without repeating themselves? So this is where we're going to start off with a model. A lot of times the table that we have in our example here is not given to us. We have to make the table and then look to see if there's a pattern. So we start off with 1 point, 1 person, 1 something. And then I go to 2. So now when I have 2 people or 2 points, I can connect 1 line between them. When I go to 3 non-collinear points, I can have 3 lines. When I have 4 non-collinear points, you can see we're going up to 6. So we're kind of just making a model here based off of what we're doing. Let me see here. Now, how is it changing each time? So when x is 1, y is 0. When x is 2, y is 1, and so on. So the x numbers are increasing by 1 each time, but the y numbers aren't. In the first one, we go from 0 to 1, it increases by 1. Then it increases by 2, then it increases by 3, and so we're seeing a pattern develop. So between each successive number, we're going to add 1 more to whatever the output was before. So from 0 to 1, we add 1. From 1 to 3, we add 2. From 3 to 6, we add 3, and so on. So if I wanted to know what the next one would be, moving on, for a 6-sided figure, I'm going to say 6 plus 4 and show that that one would increase 10 different ways. Okay, that's how many handshakes we could have if we had 6 people standing in a room where nobody, shook hands more than once. All right, so let's take a look here and trying these 2 questions on your own. See what you're able to come up with, and go ahead and pause the video and work these problems out. And when you're done, hit play again and compare your work with mine. Alright, so I'm assuming that we have some good answers on our paper. So problem number 2, describe the pattern in numbers. So again, this is where, if you want to, you could kind of make a table where the numbers that they're giving you Those are your y numbers, and you can say when x is 1, when x is 2, when x is 3, when x is 4, and so on if you want to. And but really we just need the numbers that are given to us. So here, based on what I saw, I said the numbers are increasing by 1.5 each time. So the next three numbers in the pattern would be 7, 8.5, and 10. Now problem number 3 is asking you to go back to the non-collinear points, or the handshake problem, if I had 6 people instead of 5. Well, building off of what we had a second ago, the 6 figure in the pattern would increase 10 plus 5, so there can be 15 different ways that we would be able to connect those dots together, or people could shake hands 15 different ways. Now what we're going to be doing is we're looking to see, can we make a conjecture based on our patterns that we're seeing. Again, we're looking, a conjecture is simply a statement based off of the patterns that we see. The patterns could be a true pattern, or they could be false, because it may work each and every time, which makes it true, but maybe there's a case where it doesn't work, and then we call it false. So we start with numbers 1, 3, and 5. They're telling us that those are called consecutive odd numbers, which makes sense. 1, 3, 5 are consecutive odd numbers, just like 2, 4, 6, 8, and so on are consecutive even numbers. Find the sum, make and test a conjecture about the sum of any 3 consecutive odd numbers. Now again, the question that you're given is just saying make and test a conjecture about the sum of any 3 consecutive odd numbers. The patterns that you're seeing, the 1 plus 3 plus 5, the 3 plus 5 plus 7, and so on, these are things that us as the workers, us as the students, need to start and figure it out ourselves. It's not going to be given to us. So starting off, we're going to just pick any 3 consecutive odd numbers, and we start with 1, 3, and 5. And I see that the sum of those numbers is 9. Well, I also happen to know that 9 can be found by taking 3 and multiplying it by 3. Okay? So moving on to the next pair, or the next trio of consecutive odd numbers, the 3, the 5, and the 7, if I add those together, I get a 15. Well, how else could I get a 15 by multiplying it with 3? If I can multiply 3 with 5, I can get a 15. Going on, the next set of consecutive odd numbers, 5, 7, and 9, when I add those together, I get a 21. And I notice if I multiply 3 by 7, I can get a 21. And the last one is going to give me a 27. And again, if I say 3 times something, I can get a 27 also. Now what we're noticing is that the number here, each time, the number that we multiply by 3 happens to be the middle odd number of our consecutive odd numbers. So that's what I'm looking at as my pattern here. And the conjecture here that I'm going to say is that the sum of any 3 consecutive odd numbers is 3 times whatever the second odd number in the pattern is. So let's test it. Well, -1 is an odd number. It's negative, but it is an odd number. -1 plus 1 plus 3, if I add those together, I get a 3. And if I take the middle number and multiply it by 3, I'll still get what I got when I added them together. Taking a look at the next one, 103, 105, and 107, if I do that, it does look like it holds true. So my conjecture, until somebody can prove it otherwise, does seem like a good conjecture. Now here, this is a very typical kind of thing that you might be expected to see, where you just have the question, but no framework from which to build on. That's why we practice it in our notes first. So here, I want you to go ahead and answer the question, make and test a conjecture about the sign of the product of any 4 negative numbers, and see what you come up with. When you have your answer, come back and hit play and see how your answers look with mine. All right. Ideally, you have a nice answer, a good conjecture where you were able to develop it based off of something that you created, where you're looking at a pattern. Now here, what I did is I just took 4 negative numbers. It doesn't say consecutive or anything like that, so I just took 4 negative numbers and multiplied them together. The first set of numbers I multiplied together, I got a positive 40. Next set of numbers I multiplied together to get a 36. And what I'm noticing is that even though all the numbers that I'm multiplying with are negative numbers, the product, the end result, is positive numbers. So the conjecture that I wrote says the product of any four negative numbers will be a positive number. Now moving on, let's see how can we generate a counterexample for a conjecture. Well, here in the scenario that they're giving us, we have a student makes a conjecture about the difference of two numbers. And what we want to do is find a counterexample. So their statement says the difference of any two numbers is always smaller than the largest number. Okay, so here the student may use examples like 10 minus 7 is 3, negative 6 minus 4 is negative 10. So if I take the difference of any of those numbers, I wind up with something that's smaller than what I started with. Okay, so to find a counterexample, what we need to do is we need to find a difference that's greater than the largest number. So that if we do that, we can prove the conjecture to be false. So here we see if I say 8 minus a negative number, 8 minus a negative 4, I get a positive 12. Well, because positive 12 is not less than, and that's how we read that. We read that symbol as not less than 8. The counterexample is true, so that means the conjecture that the student wrote has to be false. Because even though it's true a lot of the times, it's not true all of the time. If it's not true all of the time, we don't consider it to be a true statement. So here, this is a very basic kind of prediction that we're using. This is again something that you may have seen in Algebra 1 where you're looking at a scatter plot of the average NFL player salary. Okay, what we want to do is to make a conjecture based on the graph. Now the solution is mostly given to you based on what you're seeing. Again, for the types of problems that you'd work on an assignment or something like that, they would just give you the graph or give you something to make a pattern with so you can see, take that and make a conjecture. They're not going to just give you most of the conjecture and then just ask you to fill in the blanks here. But it is a good framework to help us to see how we can write a statement. So here they're saying the scatter plot shows that the values are going to increase each year. So one possible conjecture is that the average player in the NFL is earning more money today than in 1999. And that's not the only thing that we could say. There's probably lots of other ways that we could interpret what we're seeing in the graph, but that is simply an example. Okay, so go ahead and try answering these two questions here. And when you're done, hit play and see how your answers look against mine. All right, so hopefully we're able to have the opportunity to work these problems out here. Now here, problem number 5, there was some vocabulary that I wasn't 100% sure students would remember. So quotient is when it's the result, it's the answer of doing a division problem. The divisor is what I'm doing the division with, and the dividend is what I'm dividing into. Okay, so maybe we need to remember what those vocabulary words are. So here, the quotient of two numbers is always smaller than the dividend. Well, we want to find a counterexample that would prove that to be false. And on the face of it, it could be a little bit challenging. But if I take a number, a whole number, oh, go away and get the cursor out of the way. If I take a whole number and I divide it by a fraction, well, dividing by a fraction is essentially the same thing as multiplying by the reciprocal. So dividing by anything by 1/2 is essentially the same thing as multiplying by 2. So 4 divided by 1/2 gives me 8, which means that 8 is not smaller, or since 8 is larger than the divisor, there's our counterexample that shows the conjecture is false. Now going back to the graph in example 6, make a conjecture that could be true and give an explanation that supports your reasoning. Well here, took my pointer away because the cursor was at it. Here, so this is what I picked as, and this is only a possible answer. This is not the only answer that you could use. The average NFL salary of a player in future years will be higher than the previous years. Yes, I know, very general, very not specific, but it's just something that could be true. So that's it as far as inductive reasoning is concerned. Remember, inductive reasoning is going to be based off of a pattern that you see, and using those patterns, we're going to make statements called conjectures that we're going to see, can we make a prediction about something that's going to happen in the future. And sometimes those conjectures could be false. We could have something that's not true, and if it's not true, you're going to have to come up with a counterexample, which admittedly, sometimes doing that can be challenging. So if you have any questions about anything you're seeing, ladies and gentlemen, by all means let me know. Until next time, thanks for watching and take care.